ergonomics. Anybody here have any experience worked in ergonomics or anything like that? Done any workplace situations where they've examined activities in a workplace in terms of ergonomics?
In office ergonomic assessments.
Okay, like what kind of thing? Like like keyboards and.
Posture, their chair height, the computer's.
Okay, good. Was it because it was as a result of she's saying that she was, I want to repeat it so you can hear this on there. She's saying that she's been involved in some office ergonomics, in other words, workstations, computers, keyboards, and so on and so forth. Was that in response to complaints by the employees, or was that kind of proactive that the employees?
For that company, their highest injury is ergonomic injury, so just trying to be proactive and going around offices to educate the workers.
Right, and that's not unusual because ergonomics, musculoskeletal disorders, and cumulative stress disorders, that's one of the highest classes of lost time workplace injuries that we deal with. So it makes sense they would be interested in that, especially if there are a lot of people that are spending all day long at a typewriter, inputting data and so on and so forth, and doing a lot of repetitive things. Okay, so for starters, let's talk about that for a second. So here's my laptop over here, right? So this is Apple made this laptop. They got $1 billion designers. They got John Ivey, who's like the genius designer and stuff like that. Is this ergonomically designed, this laptop?
No.
Yeah, think so?
No.
No, I don't think so either, right? Well, let's start with the keyboard for starters, right? So I'm going to go over here and I'm going to put my hands down the way I would use this keyboard, and it's like this, okay? Here we go, right? You see my hand over here. So you guys, if you guys got a chance to mimic what I'm doing right here, like just the way you would hold your hands on a laptop keyboard. Okay, now how would you hold your hands naturally? Be like that, right? I mean, feel the difference in stress in your hand, holding it like that versus holding your hand like that. So what's one of the ways you might avoid that kind of stress on your wrist or hand, your tendons and so on?
Raise the keyboard.
Well, you can raise the keyboard as one, yeah, because that's the other thing is that if I'm doing it like that, I want to have it so that it's a comfortable height. But how about ergonomic keyboards? I have keyboards that are split keyboards, so your hands, instead of being straightened out like that, your hands can turn in. So you've seen that some of them actually separate, some of them are curved, and so on and so forth. So there are ergonomic type keyboards that are available. How about the mouse? Well, the mouse, you know, if you have a conventional mouse, it's like you hold your hand straight and you push it along like that, and you got your finger extended. And if you hold your hand like that straight, you can off to the side. That's kind of uncomfortable, right? Now relax your hand, and your hand naturally kind of turns a little bit. And you'll notice Microsoft sells a mouse which you hold. It's kind of like oblong, and it's kind of ball shaped, yeah, which kind of hold from the side rather than from the top. So that's ergonomically designed. So the thing is that you guys, 99% of you guys, I'm leaving that one guy out. 99% of you guys are young guys, right? You have young frames, young skeletons, young muscles, young tendons, and stuff like that. You haven't really experienced this stuff yet. And many of you probably don't do repetitive jobs that require a lot of repetitive tasks. But let me tell you, when you start to have this kind of problem, it can really interfere with not just your work and your productivity, but with your life. So one of the issues with keyboards is carpal tunnel syndrome, where you have a nerve that runs through a part of your wrist that controls your fingers, and that nerve, as you get swelling and you get injury in these muscles from repetitive stress and so on and so forth, your wrist can start to swell off and constrict that nerve and press on that nerve. And eventually you get to the point where you can start your fingers can start to feel numb and painful and so on and so forth. Typically it's your thumb and your two other fingers next to your thumb. For carpal tunnel syndrome, there are other conditions and kinds of activities that affect the other parts of your hand, your pinkies and your ring finger and so on. But carpal tunnel is one of the most common repetitive stress injuries. And it could be from something as simple as typing and working on a computer and using your fingers repetitively over and over and over again. As students, you might get to that point eventually, because you're writing on papers and so on and so forth. Now, it's not just at work. one of the features of carpal tunnel, one of the real nasty things about carpal tunnel syndrome is that a lot of workers will complain that while they have issues with it at work and it affects their productivity, when they go home and they go to sleep, a lot of stuff in your body swells up and changes dimensions when you go to sleep. And one of the things is your wrist, the muscles in your wrist and so on and so forth. And many people have an enormous amount of pain at night from carpal tunnel syndrome when they're not using their hands and their wrists. And it actually affects how much sleep they get. So they're really kind of attacked on both ends, at home and at work. And there's many of these kind of injuries have that kind of impact on workers. One more thing. Can somebody come up here for a second? I just want to show you something interesting about ergonomics here. Just one person. You're working in ergonomics. Come on up. I want to give you an example of brilliant ergonomics. Okay, let's take a look at this thing. Okay, now let me see here. Hang on a second. Let me give you something else to read here. Let's see if I can get out of this. And okay, I'm gonna do that one right there. Okay, so now that little screen over there, this whatever you think that is, about 7-8 inch screen, 7-inch screen. That little screen over here has the same resolution as this screen over here, right? So can you read that?
No, not at all.
Not at all, right? Okay. Here, I want you to put your hand on that mouse, and I want you to navigate over to it and try to highlight one of the words in there. So what do you got to do that? You got to move forward, don't you? So move forward towards the screen. And keep moving forward. What's happening here? Your hand is going underneath the table here, right? So this whole workstation is a complete mess, right?
It's not ergonomic approach.
Right, exactly. So they have the keyboard here on the night. They tried to help out by putting the keyboard at a height that would be convenient, but the screen's so tiny that you really have to move up, and you trap your hands underneath the slide for the keyboard. Mouses, the whole keyboard system's not ergonomically designed. You can't really even prop it up because then it gets jammed in the opening here. So this workstation alone is an illustration of how ergonomics can interfere with workplace productivity. I really can't use it. I can't see it well enough to use it. And for me to get close enough, I can't use the keyboard and the mouse then. So for me, this workstation, unless I'm working with PowerPoints that are large pages here, I really can't use that effectively. So who designed that thing, do you think? You think they knew about, they actually saw them before they bought them? Hard to believe they would actually see these things and actually try them and then bought them. Okay, so at any rate, okay, so let's talk about it. Okay. So what are we going to talk about today? We want to take a look at the risk factors and the common types of muscular and skeletal disorders. We're going to use NIOSH has, while there's no specific OSHA standard for musculoskeletal disorders and no ergonometric standard, we're going to talk about that in a second. There almost was, actually, in fact, there was an ergonometric standard for about a month or two. But that's a whole nother story. We'll get into that in just a little bit. Although there's no ergonometric standard, there are NIOSH and OSHA guidelines and requirements, mostly under the general duty clause. So we'll talk about some of those as well. We'll also identify proper controls, engineering controls, and so on and so forth, and other methods of reducing work-related musculoskeletal disorders. And keep in mind that from most of our perspective, most of the things we're going to be looking at now are things that are determined by repeated use, repeated exposure to the same kind of motions and stresses and so on and so forth. We're not going to concentrate so much today on single things things that can cause an acute injury, like one activity that might cause an injury. We're mostly looking at things that you do over and over and over again every day until eventually you can't do them anymore. Okay, so ergonometrics, ergos for work, and nomos law, so the laws of ergonometrics. A lot of this is physics just as much as it is biology as well. Okay, so We're going to look at the physical abilities of the human body, how it works, its limitations, how things are connected. And just now we were talking about the way that our hands actually are work best. What kind of positions that they're most comfortable with. So interdisciplinary in the sense that there's anatomy, there's orthopedics, there's physiology, there's physics. If you ask me, they should also include physics on here. Medicine, industrial hygiene, biomechanics, I guess physics. Labor relations, because there's issues about, of course, we work in a world where there's a lot of assembly line work, repetitive tasks, and so on and so forth. The food industry, the auto industry, so on and so forth. Okay. So, and this is an actual science. I mean, you can actually get a degree in ergonometrics and biomechanics, and people that do this kind of work are in demand all the time. Did they look around for someone, an ergonomist or anything like that, or did they just ask you to brush up on it and take a look at it?
The people in the EOHS team were trained, they were certified to do the ergonomic assessments, so I was just supporting them and they were educating me on how they were.
Oh, okay.
Yeah.
Okay, terrific. So yeah, there's an enormous need for these guys. So if you guys are looking for a specialty, you might want to consider that, because there's always a shortage of them. According to Bureau of Labor Standards, there's 387,000 musculoskeletal disorder cases, accounts for 33% of all worker injuries and illnesses in 2011. 70 million physicians' office visits, and billions and billions of dollars in lost productivity. Here's a quick chart here of some of the carpal tunnel syndrome. Is responsible for more workplace lost work days than a lot of these other kinds of physical injuries. So interestingly enough, there's a lot of different industry groups and occupational groups that are affected by this that maybe are not obvious. So here's kind of a table that shows us a number of cases of musculoskeletal disorders within different occupations and the incidence rate per 100,000 workers. So if we go to the right, we have more frequent incidences of these disorders, and if we go up, we get the number of cases as well. So the bad part here is going to be upper right-hand corner. Good parts the lower right-hand corner, bad parts the upper right-hand corner. And look at who's in the upper right-hand corner there: nurses and orderlies, right? Why is that? What kind of work are they doing that would cause musculoskeletal disorders? Not giving injections, right?
Lifting people.
Yeah, lifting patients. They have to do an enormous amount of that. Matter of fact, I may have a video or two on that maybe we can take a quick look at. Travel agents and travel clerks, not so much, right? Those are probably the clerical type occupations that we're talking about. Truck drivers, a lot of them have to load and unload their trucks and so on and so forth. They have to do some, and also repetitive stress from the driving activities that they do. History of ergonomics dates back about 300 years. I think the first recognized case of some ergonomic design in a workplace was someone designing a drafting table or a drawing table that was ergonomically designed. Been increased, okay. Population changes make this important as well, because since World War I, there's been a gradual increase in height and weight in the United States, and the aging, and generally our population is older and so on. So there are a lot of reasons why these kind of industries are increasing as time is going on. So benefits of programs: helps to prevent injuries, improves quality of work and life. Like I said, it's not just the workplace where these have an impact. Reduce fatigue and discomfort, loss of sleep and so on, increase productivity and efficiency, improve morale, job satisfaction, reduce turnover. If you keep getting work, if you can't do the work without being in pain, obviously you're not going to continue to do it forever. Ergonomic programs have been shown to reduce the incidence and severity. So there is some evidence there's a lot of evidence that this will actually, that you can actually apply this and have it prevent these kinds of injuries. Goodyear tires observed 80% reduction in lost time injuries. Okay, so you would think OSHA would have an ergonometrics rule, just like as a fall protection standard, an ergonometric standard, a hazard communication standard. You would think there would be a standard for ergonometrics, since it has such an impact on the number of lost work days and productivity. In fact, in 2001, I'll read this to you, the new Occupational Safety and Health Administration final ergonometrics rule went into effect on January 16th, 2001. It had been passed in Congress and signed by the president at the end of 2000. The ergonomics rule requires employers to comply with a series of provisions designed to reduce MSD injuries caused by repetitive motion, awkward or heavy lifting, and similar workplace motions. The new workplace rule is applicable to all employers in the general industry category. This would not include construction, maritime, and agriculture, but will include most every other type of business, including office, manufacturing, retail, shipping, service, and so on and so forth. So why didn't you apply this ergonometric standard when you were there? Well, that's because the ergonometric standard really didn't last very long. Here's an article about how there was a lot of industry backlash to it, and what happened between the end of 1999, between 2000 and 2001. There was an election, right? Right, there was an election there. There was a change in Congress, a change in president, so on and so forth. Right, exactly. So the conservative sections of Congress decided that this wasn't such a great thing, and so on and so forth, and they repealed the ergonometric standard. And they and the reason why it hasn't come up much is that in the process of repealing it, they also included in the new regulation that any new rule that OSHA was going to propose has to be cannot be substantially the same as the old rule. So what does that mean? That means if you created this rule, which you think is going to work, well, now the new rule can't be the same as that rule. So it's going to be very difficult to put in a new ergonometric standard without kind of starting from scratch. So what are these kind of disorders?
I think they can still, OSHA can still get to it with the general duty clause.
Right, exactly, general duty clause. And in fact, they have recommendations, they have rules and recommendations and so on and so forth. But the loss of that standard means that you have a fall protection standard, every workplace has to apply that fall protection standard. It's not a matter of like getting, having an OSHA inspection and having the issue of examining it under general duty clause and so on. There are specific requirements that you have to fulfill. Similarly for hazard communication, every workplace that has hazardous materials has a standard. They have to meet that standard even before anything else goes on. So it would have been nice to have that standard. So all workplaces would have examined all of these kinds of activities rather than apply them after they've had issues or something like that, or OSHA has been called in to investigate. So what are they? Disorders of muscles, nerves, tendons, ligaments, joints, cartilage, or spinal discs. Disorders that have been diagnosed by a medical history or physical exam. So a lot of these kinds of disorders, they have to do with damage to those systems, that skeletal system, the nerves, the tendons, and so on and so forth. And most of the ones that we're looking at here for these kinds of musculoskeletal disorders are things that are associated with repetitive motion or repetitive stress. Okay, generalizes disorders of musculoskeletal system produced by tiny but cumulative amounts of damage. In other words, not talking about situations where somebody tries to lift 200 pounds and throws his back out. We're talking about situations where a guy works for Amazon and he's stacking shelves and he's putting the same product on the shelf thousands of times during the course of a day. Damage occurs on a daily basis and can be caused by repetitive motion. So this is kind of a silly kind of example of it, but basically exposure one, you do some work-related activity, It causes a physiological disturbance. The body reacts to it. Your capacity is still pretty good. Your tissue status is good. You haven't had any damage. Second time, well, things change a little bit. Now you get at the end of the day, you have a little bit more damage and a little bit more damage until you have enough repetitive exposures that your body can't recover from them, and you have significant damage. Some of the symptoms: pain, discomfort, numbness, common tingling, inflammation, burning, swelling, changing color, tightness, loss of flexibility, fingers blanching, turning white, and stuff like that. So nobody here, nobody experiences this. Nobody takes part in a sport, maybe tennis or any other kind of sport, would have to hang on to a bat or anything like that. Nothing, right? Guys are not athletes, and no athletes in here. Athletes commonly have these kind of injuries because they are learning, certain kind of motions. Right, exactly. Well, yeah, tennis elbow. Literally, they call it tennis elbow because it's common. It's a common injury that's associated with that kind of impact. Not necessarily tennis, but that kind of impact. There's another nerve that runs down the inside of your arm, which affects the last couple of fingers. And I can't think of it right now, but it has another alliterative name. Whether it's called plumber's elbow or something like that. It may come up in here, but there's another one that's common in a certain industry group that winds up getting that name. Okay. So a lot of times there's many different causes, right? The type of work that you're doing, how often you're doing it, there's psychological issues with it as well. So there's a lot of things that can contribute to a culture where you wind up getting a lot of these kinds of injuries. Okay, so general duty causes. As we said, there's no specific standard, but you can apply the general duty clause. An employer has the responsibility to protect the worker. Okay, so one of the big areas that we're concerned about here is when we repeatedly have to lift and move objects. That's a big part of our world these days, right? So there are specific guidance from OSHA and from NIOSH on how those activities are supposed to take place. We're gonna try an example of that. In fact, they've developed rules and calculations for determining how you should limit repetitive motion so that you reduce the likelihood of injury over time. So some common musculoskeletal disorders: carpal tunnel, we talked about, is nerve running up through your wrist that supplies your first your thumb and your first two fingers. De Quervain's disease is, I think that's it's similar to trigger finger. Trigger finger is tendons from repetitive use of your hand. Tendons in your hand tighten up and literally get to the point where that it freezes your fingers or freezes your hand. Very often your ring finger or your thumb, and over time it can do enough damage that it's very difficult to unspool your finger or your thumb. De Quervain's is very similar to that. I think it might just be in a different finger. Tennis elbow, Raynaud syndrome. Raynaud syndrome is associated with cold. So you have people that are working, for instance, at Hunts Point Market, they're working in a cold environment and so on and so forth, and they're handling materials that are cold. So over time, the smaller blood vessels and capillaries in their hand, especially on the smaller fingers, on the outside of their hand, the last two fingers, they can progressively get smaller. They can be constricted more and more and more until they get to the point where literally their fingers start to turn numb and white, gray, blue, or white from exposure. And eventually, if they continue to work and they don't modify the way that they work and they don't protect themselves, they can get to the point where it can actually be a permanent injury. A lot of these start off as annoyances and get worse and worse and worse, and eventually can turn into permanent injuries. Carpal tunnel syndrome, many people, there are a lot of different ways to manage carpal tunnel syndrome. They have braces that you put on your hand to keep it from moving and keep you from moving in situations where You might aggravate it and so on and so forth. But many people eventually, if they want to continue the kind of work that they're doing, wind up having to get surgery to open that carpal tunnels up so that the nerve is not compressed. So there's a image of it. Passes through the wrist, entrapment of the median nerve where it passes through the wrist and the carpal tunnel, and it gets compressed. Okay, and median days away from work. We just saw this chart just a little bit. Median for all different workplace exposures is 6 days. For carpal tunnel syndrome, the median days away from work are 25 days per year. De Quervain's disease, again, it's a tendon, swelling in a tendon affecting, in this case, thumb. I think also the ring finger is also often affected. Trigger finger, very similar kind of situation. So very often it's just same kind of syndrome, but affecting a different part of the hand. Raynaud's syndrome, here's what it typically would look like. In the beginning, the blood vessels are damaged. In the beginning, you get intermittent numbness and tingling, and eventually over time, the fingers will turn white or blue, eventually wind up with loss of sensation and control in the affected fingers. Yes?
So can that be reversible? The fingers turning white can be reversible?
It depends on how advanced it is.
Okay.
The answer to that is maybe, right? Not always, but these are progressive kind of things. So if you don't address it, you can eventually get to the point where there's so much damage to the blood vessels or to the nerves that it's not easily reversible. Like pretty unpleasant, right? Okay, so, and then there's other joints, of course, in your body. They're always an issue. Tendonitis in your shoulder. And again, a lot of these, when they're from repetitive stress, it's a gradual onset. In the beginning, you don't notice any issues, then you start to see symptoms, and then the symptoms get worse and worse and worse. Lower back pain is a common musculoskeletal disorder. You have 24 vertebrae, and over time they can be damaged. They can slip out of place. They can fracture, and so on and so forth. Okay. Okay. What are the causes? What do we need to look at in order to decide whether a workplace activity is likely to contribute to these kinds of injuries? I would have put number 2 first, repetitive motions. Anything you do over and over and over again is going to be likely to be something that might cause injuries. Awkward postures. Okay, anybody who's ever picked anything up knows that if you pick it straight up, works pretty good. Pick it up awkwardly or in an awkward posture, there's a lot more strain on your body and so on and so forth. Forceful exertions. So how often you do something, what kind of strain you're under because of posture, how much force you have to use is another factor. Pressure points, places on your body that if you have to, when you're doing your work, you're required to say spend a lot of time on your knees. If you're a flooring guy, you're putting down tile or something like that. You spend a lot of time on your knees, and your knees become pressure points. They get affected by that repetitive injury from moving around a floor in order to put down tiles and so on, or nail down floors and so on and so forth. Now, and we'll get back to that in a second. Static postures, situations where you stand in the same place. Now, if you guys, anybody ever do any kind of work where they've had to stand by a counter day, for an 8-hour day? I mean, after a while, your feet are cramping and so on and so forth, because even though you're standing still, your feet are constantly adjusting to balance you. So even though you're standing still, your feet are doing a lot of work, a lot of repetitive work. Vibrations, we're going to be talking about vibrations next week a bit more, but vibrations can contribute to this as well. And the low temperatures, that cold that we're talking about that constricts blood vessels repeatedly. Okay, so now some of these things are things that you can examine a workplace activity and say to yourself, well, gee, there are some obvious fixes to this. Guys that do flooring, they wear knee pads, right? Or if you see a lot of guys that do flooring, they'll have like these dollies, these roller carts, they slide across the floor on and so on, right? So So there are mechanisms that they can use to protect themselves from a lot of these. One of the mechanisms that an employer can use to protect a worker is not have them do the same activity quite as much. In other words, give them a selection of different activities to do rather than do the same activity all the time. Risk factors, duration of the exposure. If you're doing 8 hours a day for 20 years, it's different than doing it once a week. Frequency of exposure. If you're lifting the same size object 10 times an hour, or if you're lifting it 100 times an hour. Intensity of exposure, how much it weighs, and so on. Combination of risk factors, more weight and more duration, and so on and so forth. Length of exposure risk can be months or years until it becomes a concern. Intensity, the weight in pounds might be considered intensity. Frequency, often a problem in assembly type tasks, assembly lines, sorting tasks, stocking, loading or offloading materials, inventory products, and so on. So I was just looking at, I was in the supermarket the other day, and there was a guy that was stocking the shelves, and he was in a constant crouched position filling the bottom shelves. And you know what he was filling? You know what he was putting in there? Putting in flour and sugars in the baking in the row of baking needs and stuff like so. He's putting in flour and sugar. How much do flour and sugar bags weigh? Anybody know? Huh? 5 pounds, right? Typically 5, some of them 10, a lot of them mostly 5 pounds. They're about the heaviest thing you handle in a supermarket, right? Okay, so he had a cart and the boxes were stacked up. He had them on the cart, so you had to take them, crouch down, put them down near the bottom. So they're in the bottom row. That's not very ergonomic, right? You have them on a cart over here. You want to put them in the middle row. Why isn't he putting them in the middle row? What's that?
That's not where they go.
Well, I mean, you put them, you decide, the store owner decide. Why is the store owner not tell them put them in the middle row? Make it easier for yourself. Okay. The stuff that the stuff that they're paying to promote gets into the middle row. In other words, if Campbell wants their soup in the middle row, it goes in the middle row, right? The stuff you don't make a profit on goes out of sight, goes up high, goes down low. It's not ergonomic. They're not thinking ergonomics. They're thinking turnover and profit. Some of the distributors will pay them for position. It's no accident Coke and Pepsi are at the end of the aisles, right? They're paying for that position at the end of the aisle to have their product at the end of the aisles. Yeah.
Okay, I have a comment on that. Like I've been to some stores where the level where they put their items, like their merchandise, can be passed, mostly in Europe.
Right.
And there was actually a store that's from Europe that is illegal. I don't know if anyone's been illegal. Most of the shelf is like not above,
Oh, it's a low. You're not like in the United States where they're stacked way up high, right?
Getting the items, you have to like go get a ladder.
They have in Europe. They have an entirely different viewpoint on food and so on and so forth. First of all, number one, what I know from Europe, from Italy, for instance, is people in the United States, they go to Costco, they shop for the next 3 months, right? People in Europe, they shop for the next 2 days. Right? That's why they're always using fresh ingredients. They go to the store, they shop for 2, maybe 3 days in advance. They don't stockpile stuff. So they don't need supermarkets with enormous, vast quantities of stuff, and the other thing is that, yeah, of course, that, that lot less, there's also a lot less different, like repetitive kinds of stuff, same kind of stuff over and over again. Yeah.
I have a question. So the sugar and the flour weight 5 pounds, but they put the heavy objects at the bottom, the lighter ones at the top.
Well, the only problem with that is that the guy's got to take it from out of a box, lift it up, put it down, and put it in. So in other words, think about this. He's got to go over here. So it's an angular issue. He's got to pick it up, come over here, and put it down there into the shelf, on the lower shelf, while he's crouched, while he's in a very awkward position. Where if he could be if it's on a cart, right? He's got the box on a cart. He could just pick it up, go across, and put it in. Pick it up, go across. So, I mean, ergonomically, it would be best to have it that way. Now, that doesn't mean they can't do that, put it in the bottom shelf. If they gave the guy a mechanism, like some sort of, vehicle, some thing that he could sit in, or if they could supply him with the product, at a height where he didn't have to lift it up and over and back down again and put it, some mechanism for getting it in there easier. Now, obviously, in that situation, they're going to want they want at eye level the product that brings them the most money. So that's an economic decision. But they could certainly, this guy was just, literally just crouched, like no mechanism to, like no seat, nothing to sit on or anything like that. So, other places might have better mechanisms for doing this, right? But for the most part, from what I've seen, it's all stocking in supermarkets, all manual labor. They have carts. For the most part, they're hand trucks and boxes. They drop the boxes on the floor and the guys just fill it from the boxes, right? So there's an industry that could use ergonomists, right, to work with this stuff. Now, you may argue, on the other hand, that like, gee, usually most stock people are younger people. They do it for a few years, they move on, do something else, but there's a lot of guys that continue to do that. So my family, I was the only one in my family born in the United States. They came over after the war. So I'm the baby in the family, right? So they were here in 1947. My oldest brother was about 14 or 15 when he came over here. And he worked as a stocker in a supermarket, his first job. He could barely speak English, worked as a stocker in a supermarket. And one of the things we used to have fun with on holidays when we used to get together for meals, or Sundays we get together for meals, is we would be able to yell a number at him, and he would know exactly what Ronzoni shape that number was. And Ronzoni has like 200 shapes or something like that. He had them all memorized. Like 37 was, I have no idea, but 37 was like linguine or something like that. He would know every number. So anyway, yeah, stocking's and stocking, because we have so much of what we do is retail merchandising. This is a big issue everywhere. And again, as you mentioned, everything's like up to a certain height. Here in the United States, now you have guys that have to get on a ladder to stock things, right? And Costco or Home Depot, right? Now you introduce not only that, but the hazards associated with the machinery to move and lift all these things, especially Home Depot. A lot of that material is very heavy. Okay, so product stocking, T-typing, frequent mousing and stuff like that. These are all tasks that you do a lot of. You keep doing over and over and over again. Force, of course, has some impact on this. These 5-pound bags are obviously have more impact on the worker than stocking little Jell-O packets and stuff like that. Greater force, greater risk of musculoskeletal disorders. Heavy physical work is associated with lower back pain, and that's no secret. I put the same air conditioner in the window every year for 20 years, right, till it was almost dead. And then one year we had a couch or something we had put next to it, so I couldn't get straight into the window. Right? So I had to pick it up, walk over to the window, and kind of go like this to slide it into the window. Well, I went over about 12 inches like that. I saw stars. I dropped it. I was on the floor. I had to crawl to the phone to get my wife to come home and help me out. Back those, we didn't have cell phones. But literally every year, picking up, putting it in the window, doing exactly the same thing. One year, just picked it up, and just that change in stress. Because I didn't move the couch. I just didn't want to, rather than put it straight in. So let that be a lesson to you, but we're going to talk about that. That kind of, you want to handle loads in front of you. You don't want to handle them off at an angle. And when you do have to do that, you want to pick them up, walk, turn, and so on and so forth. You want to keep them in front of you. Personal experience on that one. Okay, so now this is physics. This is biomechanics or physics. Our bones we're machines. Our bones are connected with muscles, and these muscles act in different ways. Our hips, in this situation, is a fulcrum. So we hold something way out, we put much more strain on our body than if we pull it in, right? Because that's a longer moment, right? So there are things that we can calculate here to determine how much stress that we're putting on our body. So some of the things we can control: reduce the weight of the material that we're handling, handle smaller quantities, control the balance of the objects. In other words, make sure that we have good grips on them, that we can We control them better. Maintain fit tolerances. I think they mean physical fitness in that case, and mechanical aids. Nurses, what do nurses use for mechanical aids these days? They have slings, they have lifts and slings and so on and so forth. They're trained on techniques in using various kinds of techniques to move patients from one bed to a moving cart or something like that. And they, if you ever watch them work, they've been trained on how to, rather than lift a patient, how to use sheets to roll them and to move them. You've seen them do that, and it's very effective. They take a lot of strain off of them because, you know, trying to lift a person is like, it's kind of hard, right? They don't have people don't have handles on them, right? So it's much easier to grip those sheets and so on and so forth. They have slings they can put under the patient and with a tripod, and they can lift the patient, move them into a wheelchair and so on and so forth. They have beds now that are pneumatic, that you can pump up one side to turn a patient and so on, and then pumped up the other side to put them back into the same position. So they're getting more, because they're one of the areas there that have so many injuries, and that nowadays are a really important occupation. In other words, hard to find nurses. You don't want to lose a nurse to a back injury because she's really hard to replace these days. So nurses going to make more than you guys do in 5 years. Watch, So don't feel bad about that. They work harder. So at any rate, they have mechanical aids that they have for nurses, and in some industries, the grocery stores, that they don't have those mechanical aids because they're economically not as viable in those kinds of situations. Safe lifting. Make sure movement is lateral. Optimal vertical lifting is between knuckle height to shoulder. In other words, that range above your knees. If lifting must be done, in other words, not from the floor up, if you can avoid it. If lifting must be done, make sure it's done in front of the body. That was my problem. Materials should be compact and easy to grasp. Had handles, it's great. You've seen a lot of large, bulky delivery boxes, which are very hard to handle. Once in a blue moon, you'll actually see handles on it. The inserts or handles somewhere to grab it, and so on and so forth. Okay, alternatives to lifting: use carts, handcuffs, hoists, conveyors. Slide the objects instead of lifting them. I'm an expert at that. I slide everything now. I lift nothing. Store heavy objects. I just picked up at Home Depot. I just picked up these things, these little discs. On one side, it has like carpeting, and the other side, it has very shiny plastic, very hard plastic. And the deal is you put them under things, and then you can, like the carpeting is when you're on a hard floor, you can put it under it, and you can slide it across the hard floor. And the disc, you turn them over, use it the other way when you're on carpeting to help you move things over. And I have it under a few things. And I just bought one at Home Depot. The reason why I came up, I just bought one at Home Depot. I brought it home, and I said, gee, where am I going to put this to find it when I need it? I said, I know where I'm going to put this in this box over here. And I opened that box, and I had 3 more of those things, 3 more boxes of those things sitting in there. How many times you do that? You have a tool, you can't find a damn tool, and I couldn't believe it. So I saved the receipt. I'm bringing it back this time. So at any rate, okay, so forklifts, other mechanical equipment, other devices to handle heavy materials and so on. So this is stuff that can be quantified, right? So NIOSH has done studies on this, and they have put together a lifting equation, an equation where a employer can calculate for a repetitive stress situation. He can calculate how much weight that given how much weight that a worker can handle, how much repetitive motion with that weight he can handle, and take into account all the different variables that might be involved. Okay, so RWL is the recommended weight limit. In other words, if a person's job is to pick up a 5-pound bag of sugar and move it into this shelf, how many times should he be able to do that over an 8-hour workplace or workday, right? Or a 4-hour workday, 3-hour workday? How many times should he have to be able to do this? So recommended weight limit. So if he's got to do it, if he's got to do something 1,000 times, the recommended weight limit might be only 5 pounds. If he only has to do it 100 times, maybe the recommended weight limit is 10 pounds. And if you had to do it only 5 times, maybe recommended weight limit is the maximum. And the maximum in this formula, anybody know what the maximum in this formula is? It's really in kilograms, so it's an odd number. It's 51 pounds. According to NIOSH, 75% of females and 90% of males should be able to lift 95 pounds. These are healthy workers, right? 90% of males and 75% of females should be able to lift 51 pounds repeatedly safely. Not, and then from that point, right, starting at 51 pounds, that's safe for them to lift. From that point, you're going to work down, depending on how often they have to do it, what kind of motions they have to use, and how angular it is, and so on and so forth. How many times they have to do it during a work day, and so on. And that weight limit is going to go down based on if they only have to do it once an hour, 51 pounds. Now, anybody see a problem with that? Okay, what is that? For instance, if you have a softener, right? I worked in the water treatment industry for a long time. You buy a softener, you need salt for the softener, right? What size bags does salt come in? Anybody know? 80-pound bags, right? Most chemicals come in 100-pound bags, right? Or drums, 400-pound, 500-pound drums, right? So, I mean, there's not too many things that come in 50-pound containers. I guess 50 pounds, you do have some things that come in 50-pound containers. But there's a little bit of issue applying this in some situations because you're just not dealing with that lower weight. And in fact, I can give you some examples where it's obviously not applied. What's the weight limit for UPS? What's the heaviest weight a UPS worker is supposed to be able to lift? Himself, take on the truck and deliver himself. Anybody know? Right now it's 75 pounds. 75 now. You know what it used to be about 10 years ago? 150. Well, they give him hand trucks, that would go out on a lift gate and they give him hand trucks, but he'd be expected to handle 150-pound load himself, right? I got a piece of furniture delivered. It was 300 pounds. 2 guys brought it up the stairs, brought up a set of turning stairs. 2 guys. And the guy on the bottom was doing 90% of the lifting. 300 pounds. I'm not making this up. That was the weight, the delivery weight on this, package, a little less, maybe 250 with all the packaging gone and the wood and all that kind of stuff. But it was 300 pounds and 2 guys brought that up a set of stairs. Huh? Yeah, I tipped them well. Yes, absolutely. I couldn't believe, my feeling is that it's ridiculous, to send 2 guys out with that kind of load. So at any rate, but some companies are aware of that. I don't make deliveries like that. I had we had a kitchen redone a while ago, and we ordered all of the materials from Home Depot, and we were going to get them to do the whole thing, but turned out that their contractors only do a portion of the work. There's certain things they don't do. They don't strip wallpaper off a wall. You have to go to get another contractor to work with their contractor. You have to go find your own guy to do some of the work. So it didn't make any sense, but we bought everything from them, the appliances, all the stuff. They did a great design. They have design stations there now. Great design, fabulous work. But we need the materials. So the materials were delivered. So I had to take the delivery materials, right? So I was a little bit trepidatious about it, because I have my experience with some of these other outfits, send 2 guys to deliver 300 pounds of stuff. So I get a knock on the door, and it's a guy with a pad. So I'm delivering all your materials for your contractor for Home Depot, or the contractor I was using, but from Home Depot. And it says, oh, okay, it's tile and flooring and all kinds of stuff, right? So I said, oh, okay, great. But I looked out, I didn't see a truck around. So yeah, my truck's around the corner. It was an 18-wheeler around the corner, right? So I said, how are you going to get it here? You can bring it in the back. I live in one of these community drives, so like there's a dilapidated old garage back there. I can put stuff in. I can't fit my car in it. It's literally too small. It's made for cars from 1935. I don't know if you know that, but cars in 1935 were a lot shorter. So at any rate, so So now it's just houses stuff. So at any rate, I told him, can you bring it back here? And he says, yeah, no problem. So he disappears. Next thing I know, he's driving this giant forklift with all these pallets on it. I couldn't believe it. So he brought it around, drove it right up to the garage. One of them was able to just drop into the garage. The other one he dropped in front of the garage, and he opened them up and just piled stuff on top of the other stuff. But he was set for that. He even had stuff to help him handle the loads, like straps and things to like get boxes, pick them up, put them on top, and so on and so forth. But I don't know what their other delivery stuff is, but their construction material delivery, those guys are trained in ergonomics. They're equipped. They know what they're doing, and they have every piece of equipment that they need to actually make the delivery. Not everybody's like that. So other outfit delivering furniture, 2 guys, 300 pounds, an impossible situation. I was just glad the guy made it out of the house in one piece, and I didn't have to increase my umbrella policy. So at any rate, so recommended weight limit. Okay, so what's going to affect this recommended weight limit? Okay, well, first of all, the load, the weight of the thing, the horizontal, the height. Now, remember, this object that you're going to move, it's going to start in one spot and go to another spot. So we got 2 calculations to do here. One is, what does the guy have to do to get to that position to grab the thing? And then what does he have to do to move it from here to there? So there's really 2 calculations involved here. So what's the horizontal position of this thing? What's the vertical? How much do I have to move this horizontally? Well, first of all, in getting to the device, where is it horizontally? Is it on the floor? Is it a foot off the floor? Where is it vertically? Now he's going to move it somewhere else. How much does he have to lift it? How high? How much does he have to move it from left to right? What's the distance? How often is he going to have to do this every hour? How much of this load that he has to pick up and move, is he going to pick it up straight in front of him and put it into something? Or does he have to pick it up and turn 30 degrees and put it into something? That's asymmetric multiplier, that little an adjustment for that. A coupling multiplier. How easy is this thing to pick up? Is this thing like these, I guess, what would have holes on the side of it? I don't know, 6-pack, not 6-packs, right?
No, great.
Crates, the very kind of crates would have a milk crate, right? Does a milk crate have handles where you can stick your hand, lift it up and put it and move it? Or is it just a awkward box with no handholds or anything like that? How good is the coupling mechanism? How easy is this pick this up? Can he get to it from the side and pick it up, or does he have to get his hands under it to pick it up? So all of these things are factors. And for each of these factors, NIOSH has put together a calculation. LC, load constant, HM, horizontal multiplier. Now that's not the inches. That's a calculation based on the number of inches. We're going to take a look at the formulas for that. So now, of course, NIOSH wants to warn you, it's like everything else, this does not apply to 8,000 different things. You can use this for certain things, but not everything. Okay, this doesn't apply to tasks that require lifting with one hand, for anything over an 8-hour workday, for things that you do while you're seated or kneeling, for unstable objects, while carrying, pushing, or pulling, with wheelbarrows or shovels, with high-speed motion, faster than 30 inches per second. That's running with something. Unreasonable foot or floor coupling in unfavorable environments outside of like basic room temperatures and so on and so forth. So this is meant for a manufacturing situation, right? Or a stocking situation and so on. It's not meant for heavy industry or for a construction site. And so I think it actually excludes construction sites. Okay, you might have noticed that the ergonomic standard that they passed for a little while, that also excluded construction standards because it's so hard to define them uniformly. Okay, so how does this work? This lifting equation. Well, the load constant, that first thing, load constant, which is the starting load, the maximum load you're going to work with repetitively, is 51 pounds. Now, that's not to say you can't lift more than 51 pounds. You just don't want, Naya says you really shouldn't do that repetitively. Okay, so horizontal multiplier, that's going to be 10 over the height of the object. Vertical multiplier is going to be a form based on this formula. How are we doing on time? Am I doing something wrong here? No, okay, good. I thought it was running out of time. Yeah, no problem. I understand. So all of these factors, while they're metric or inches, in other words, they're all in metric or inches, they're actually, each one of those factors is calculated based on a distance or a weight, where the thing is positioned or where it's going to. And you're going to use these formulas. It's kind of a pain in the butt, right? Well, most people don't do this. What they do is they use an Excel file or something like that, or there are apps, phone apps now, that you can use to input all these various factors. Okay, this is these are various tables to use with this. In other words, that frequency FM, we get that from this table. Coupling multiplier, we get it from this table down here. If the coupling type is good, in other words, got handles, it's easy to handle, then that multiplier is 1, and so on and so forth. So we're going to use these tables to do this. This is a job analysis sheet that an ergonomist might use to apply this formula. Okay, and this is a typical task that we might work with here. So I don't know what this is. This could be a roll of paper or a roll of sheet metal or something like that, but he's lifting it from one spot up to another spot. Okay, so he's going to have to move forward, lift it, and so on and so forth. It looks like it's got good handholds and so on. And I'm going to pass this around so we can do this together. Okay. Tell you what, as we're passing this around, let's take a break for 5 minutes. It's 9 o'clock. Good time for that. Yep, one page, and there's one page of this, which are the other tables. Do I have anybody online? Let's see. Oh, nope. I have one person online, Bill. Hello, Bill. Bill, I hope you can hear my voice and see my screen. Ah, good. Thank you very much. That's unnecessary, but appreciate it anyway. It won't affect your grade. Bye. I'm going to put you on pause. Okay,
This
guys,
conference
get
will now
started
be
then.
recorded.
Okay, so we have a task. This guy's lifting up this roll of stuff, whatever it is, from the floor. Now it's got a handhold on the side. He's not actually picking it up off the floor. It's the position of his hands is what we're interested in, not the bottom of the object. The position of his hands, where our starting point is. So we have a chart here going across, and we can start by putting in the actual dimensions and weights in here so that we have it, make it a little easier for us to deal with the actual calculations. Okay, so in this case, first thing we want is H, is the horizontal location of, notice there's 2 rows here, right? We're talking about the start and the end here, right? The horizontal location, and the top row, the horizontal location of his hands. So how far off the ground are his hands? Looks like is that 15 inches? You guys read that better than I can? 16 inches? Okay. And next, we're taking a look at the vertical location of his hands. Oh, I'm sorry. Horizontal location of his hands was 20 something inches from his core. Yep. And vertical distance was that 16 inches. V is 16 inches. And then next is vertical distance travel. The vertical distance of lift is determined by subtracting the vertical distance at the start from the vertical location at the end. Okay, so what's that going to be? Vertical location at the end is, again, I can't, guy's got young eyes. What is that, 60? Oh, it's such a horrible drawing. Yeah, something like that. Okay. Well, I'll tell you what, I'll take it from my notes. Actually, I'm gonna go to a spreadsheet here, actually. I'll go to PowerPoint, so we save some time on this rather than struggle with it. And this is in the PowerPoint. You have two versions of it. One is every slide's an individual page, so you can kind of flip through it quickly. And the other one is 6 pages to 6 slides to a page, so that you can work with it a little easier if you want to. But this, all it is actually on the PowerPoint. Let me get back to it here. Window. There it is down there. And so if we can't get the formula and the,
So it's 15. No,
yeah, it's 15. I think it's 15 because I couldn't read 15. I couldn't read it anyway when I did that either.
and then the other one is 89.
Yeah, okay. Let's take a look at the origin. Okay, so our load constant is 51 pounds. That's always going to be 51 pounds. Okay, the horizontal factor is 10 over the height that it's starting at, which is horizontal. It's 23 inches from the core of his body. He's got to reach out 23 inches. Okay, that turns out to be 0.44. The vertical multiplier is 1 minus 0.0075 times the positive value of the vertical distance minus 30. So it's 15 inches off the ground minus 30. Multiply that all out, it comes out to 0.89. Let's see, DM. DM was, let me see if I remember, let's see what that was. DM is the distance multiplier. And so the distance multiplier is 0.82 plus 1.8 over the distance that he's moving it, which is 48 inches from the 11 inches to, from, I guess, no, 48 inches is, on the far right, yep, 48 inches. Okay, and the angle multiplier, the angular multiplier is 0 because here's A is the angle. The angular multiplier is 0 because he's just lifting it in front of him, putting it in. If he were turning it 30 degrees, then he would that would have a different multiplier. I'm not sure. I don't remember off the top of my head if that's radians or degrees or what the units is supposed to be for that. See if it's in here. It doesn't say there. It'll say here. I also have, I'm not sure I have this on Blackboard yet, but I also have instructions on individually what each one of these factors, how it's calculated and what the unit should be. So yeah, it's in degrees. You would use degrees there. No twisting is 0 degrees.
No twisting, so it's based on twisting, so it's not based on reaching.
Right, no, angular. In other words, if he has to turn to a different angle. In other words, if he has to pick it up, move this way, that's 90 degrees. Or if he's got to pick it up, move this way, it's 45 degrees, for instance. And there's a starting angular point and an ending angular point. So in other words, could be that when he picks it up, he's got to pick it up because he's got to kind of like reach around. He might have to pick it up at 15 degrees or 20 degrees, right? Then he picks it up and he straightens out, but where he's putting it is 0 degrees because it's at the destination 0 degrees because it's right in front of his body when he's working with it. So that is whatever angle his body has to be in order to pick it up or to put it down. And then next we got coupling. Okay, so coupling has 3 factors, 1, 2, or 3. Coupling means that it's easier to handle. You have handles on it, you can grip it adequately, and so on and so forth. If it's a big box and it's bulky and it's very difficult to handle, that would be 3. If it's got handles on it and it's you can get a good grip on it, that would be 1. Okay, the load is the weight of the object to be desired. lifted. We know that I think it's 44 pounds in this picture. Okay, and 8 is the duration, the lifting duration. How often you're going to have to lift it. Short duration is less than 1 hour with a certain amount of recovery time. 2 moderate is between 1 and 2 hours, and a long duration is going to be between 2 and 8 hours. And you would use that in the formula for that part of it. Okay, so, and here's a version of it that's been filled out. Let's see what we have for ourselves here. So if I go back to my PowerPoint, let's look at the actual calculations. So the first part of the formula is 51. First multiplier is 0.44, 0.75, 0.86, 1 because 0 degrees. 1 was for the frequency. Frequency is not often, and yes, the rest periods. It's under 2 hours, and the coupling is good, so we got a 1 on the coupling. When you put that into, if you multiply 51 pounds times all of these different factors, you get 14.5 pounds. That's for the destination. In other words, the process of moving it from here to the destination. For the origin, which I really should have done the origin first. For the origin, we do the same thing again, and this one's a little bit different because of the different locations that he's working at, and it's again 0 for this, and so on. And when you multiply this out, you get a 16.3. So what is that telling us? That's telling us that our lifting index, in order to meet the NIOSH recommendations, that the lifting index should be equal to 1. In other words, 1 represents lifting 51 pound 1 time directly in front of you. But if you got to do it, if you have to, depending on the weight, the motion, what you have to do with it, and so on and so forth, now you have a new index. So both your origin and your destination should have an index that doesn't exceed 1 if you want to protect the worker from repetitive stress injuries. That doesn't mean it can't exceed 1. Okay, it means that optimally you're aiming for a lifting index that's less than 1. Between 1 and 3 suggests that there's the potential increased risk for musculoskeletal disorders over a long term, right? But it's not in the real danger category. Once you get over 3 times the lifting index for either origin or destination, then you wind up in a situation where you might have a real high risk of musculoskeletal disorders over a period working at that rate. Okay, so how can you adjust this? If you're over 3, well, we're at 3 as a matter of fact on destination. So how can we adjust that? What's that? Lighter weight, yeah, more shorter duration, lighter weight, lower frequency, reduce the horizontal distance that he has to reach out to pick it up, reduce the amount of height that in other words, put it on something so he can lift, so he doesn't lift it as high, lift it from a higher position rather than the floor. So there's a number of things that you can manipulate in this formula until you get that number down to a level that you're happy with. Yes?
So how does this work for weightlifters? I mean, do we break that rule?
Wow, weightlifters. Yeah,
I do that all the time.
Weightlifters?
Yeah, I'm saying I break the rule. I mean, I twist and I lift more than I should.
Are you saying you're a weightlifter?
No, I mean, I break this
yeah. It's not intended for that, right? Remember, we went through a whole section here where said that what kind of activities it was intended for. It's intended for a workplace. It's intended for work, yeah. But obviously, weightlifters, they actually limit. I mean, a weightlift is not going to press a certain weight repetitively. That is so great that it's going to injure himself over the long term, right? In other words, they have trainers, and the trainers will limit the amount of weight that they can lift, or they'll train them up and also you're not working with an average worker who might be a female worker, might be a male worker, might be in different kinds of condition and so on. Yes.
44 divided by the destination, 44 divided by the origin. I was wondering where it came from.
44, where is it?
When you're going, if you go back to the work on the slide.
Yeah, let me get the PowerPoint back up.
So the lifting index that you have, previous, yeah, it says 44 pounds. I was wondering where it
That number's the actual weight.
I thought it was 51.
No, 51 is the maximum weight. That's the lifting constant.
Okay.
That's back in our formula, that was the lifting constant. Our lifting index is, in other words, the optimal weight that you would want the worker lifting in that motion repetitively during a work day is 16.3 pounds. The actual weight that he's lifting is 44 pounds. So he's lifting 3 times the weight that NIOSH is recommending that you have him lift in order to protect him from repetitive stress. Now, so in other words, you want that index to be what? You want what NIOSH recommends to be the same thing as the weight or less, the weight to be less or the same. So you got a lifting index of 1. Okay, but they're saying that like if you're in the range of 1 to 3, NIOSH says that you're in a zone where there's increased risk of repetitive stress injury. But once you get over 3, then it's really a hazardous situation for repetitive stress, right? So in other words, if you were lifting 50% more, 1.5, the index was 1.5, you were lifting, the higher number here is lower number is 14 pounds. So basically you don't want the worker lifting more than, the lower number would be lifting more than say 15 pounds. If he's lifting 17 and a half, it's a bit more than the NIOSH recommends, but it's not at the point where NIOSH is defining that as a high level of risk.
This is not accounting for the strength of the person.
I'm sorry?
It's not factoring in the strength of the person.
That's interesting. No, it isn't. This is like kind of a general principle for workers. And in fact, really, if you look at these weights that they're using, they're not real heavy weights in terms of what people use in manufacturing or in industry. So remember that 51 pounds, that was based on what 75% of females and 90% of males can lift, right? So they are covering the majority of workers, right? So you might have 10% of workers that really this wouldn't apply to because they don't have the strength to lift this kind of stuff. But yeah, you're right that like they kind of ignore the fact that it's not universal. But then if you made it, it's impossible to make universal because eventually you're going to have workers that can barely lift anything, in some situations, right? So, but the fact that they're covering 75% of females or 90% of males should be able to protect themselves with this standard, that makes it pretty general. That covers a lot of the worker population. Okay, and let's say use of back belts. Anybody here use back belts for lifting? You've seen people use them and so on, right?
Yes.
They're really not protective, right? I don't think anybody really feels that. Yeah, they're really not protective. They can increase comfort, but they don't actually protect you from any kind of strain. Not substitute for ergonomic design. Okay, repetition is, a lot of people use them because they feel more comfortable with them when they're lifting. Repetition is repeating of the same task over and over again. You lift frequently, you can tire out the muscles, make them more prone to injury. The amount of stress depends on how quickly you do it, how long you do it, how much force the job requires. A lot of this is included in that formula. Okay, high risk repetition rates for your shoulder, more than 2.5 times per minute. For your upper arm or elbow, more than 10 times per minute. For your forearm or wrist, more than 100 times per minute. For fingers, more than 200 times per minute. What kind of activity might be repetitive for fingers? Typing, yeah, right, exactly, more than 200 times per minute, right? So I know people that can type faster than 200 strokes per minute, right? Easily, right? I know people can type 100 words a minute, right? So that would exceed that. But they don't type all day long at that rate. Increase the variety of tasks performed. So in other words, you can if you have tasks that are repetitive like this, You can have several workers trained to do them, and then they can trade tasks. So this guy's using is screwing devices together, and the other guy is lifting boxes. They can trade tasks midday. So they switch off, and neither one of them is doing the same job for 8 hours during the day. So job rotation. Hand-intensive work. Some workers have tasks that, by their nature, they're doing the same thing all the time. Butchers, right? At Hunts Point, for instance, they're constantly cutting the same cuts of meat, the same slicing action, and so on and so forth. Here's the poultry industry. Is infamous for this, for these assembly lines where they're handling product and so on and so forth. And it's cold and so on. So it's a lot of different exposures. So make same motion repeatedly, cause a lot of wear and tear on joints. So these kind of workers frequently have issues with this. There was a name for butcher's wrist or something like that, because they used to cut with straight knives. They used to cut up beef sides with straight knives, but now they almost universally use these ergonometric knives that are bent at like a 80-degree angle or something like that, so they don't have to bend their wrists to do a cutting motion. But so there's been a lot of reduction in those kinds of injuries. Reducing repetition, letting power tools, machinery do the work. Pretty soon robots, I guess, right, to a large degree. Spread the repetition work out during the day. Take pauses. You may have noticed that in the formula it discussed, they mentioned how long you're doing the activity and how much time that you would have for breaks between the activity was in one of those categories. Rotate the cast with coworkers if possible. Change hands or motions frequently. Okay, ACGIH hand activity level. Okay, so this is another attempt at some sort of standard for determining that if you're going to do something where your hands that involve some force or repetitive motion, how you can determine what a good limit for this is. And it's based on how quickly you do the task, how much force is involved in it, and how much repetition is involved. Okay, strength. And of course, as you mentioned, there is the issue of fitness and so on. So you can test workers to make sure that they're fit for doing the particular job. You can measure their grip strength. You can, here's an examination of grip strength by gender. You can examine how they're doing the work. For instance, handling materials. A strong grip using your whole hand is 5 times stronger than what you can achieve by using your fingertips in a pinch grip. Here's hand-intensive work gripping. So here's a repetitive task. Somebody works in a bakery that's decorating cakes all day, right? You can imagine, because if anybody's ever done that, where they've done piping on cakes and stuff like that, it's a lot of, you put a lot of force into that with your hand to squeeze out the piping, and over the course of a day, it can hurt after a while, right? You do that for a lifetime or a working lifetime, and it can affect you after a while. Pinching with fingertips. Other factors: grip strength, bending your wrists, picking up slippery items, wearing poorly fitted gloves, and having cold hands can increase the risk of injury. Hand-intensive work, gripping and pinching and bending, the amount of repetition, all of those things increase the amount of risk. Awkward postures. I mentioned to you about my experience with that. Kneeling, twisting, working overhead, bending, reaching far in front of you to pick up something, and working with a bent wrist. Neutral postures. Now, when we're talking about the keyboard, we talked about neutral postures there. There's also neutral postures for, say, seating. So ergonometric chairs will help you adjust the seat to the point where you have a neutral posture, where you can feel that you're not stressed, where you have a keyboard height that you can tell is that you're not, you don't have to be stressed, have a constant stress or tension in order to keep your hands at the right height for the keyboard. So some awkward postures illustrated here. Back bent forward, back bent backward, extension, twisting at the waist, bending laterally, and so on. Work activities that involve that are more likely to cause injuries. Oh, there's some awkward squatting. There's somebody stocking shelves, as I mentioned. That's exactly what it looks like. Okay, reducing low work. In other words, bringing things up to a manageable height so you don't have to crouch or bend over to do the work. Using a stool to work for ground level. Using tools with longer handles. Alternating between bending, kneeling, sitting, and squat. You know, I bought one of those. I was at Home Depot about a year ago, and I bought one of those grippers. You know, things that they would use to grab stuff off a shelf there. And I liked it so much, I bought one for each floor of our house. So I don't have to go looking for the thing. Because wherever it was like two staircases. It was in the basement, on the second floor. It's in the basement. On the basement, it's the second floor. So I got one on every level now. So I've really cut back on how much I wind up bending over to pick things up. Ergonomics at work, reducing low work. And here you can see that they put together a makeshift stand to hold material so that instead of having to reach down, bend down, and go into that box repeatedly over the course of the day, now it's at a height where you can just reach into it. Reducing high work, in this case using an extension to water plants that are kept at a high level. This guy's not doing so well. He doesn't have a ladder, a rollabout ladder that he can use to help him reach those materials. Rolling platform or rolling stairs, use tools with longer handles, extension. That sprayer was an example of that. Limit overhead storage to infrequently used items, and bring the work down and tilt for easier access. Temperature, anything below 65 degrees, thought to be concerned about workers' numbness and workers' hands and so on. Not also affecting grip and affecting their control over objects. So dealing with the accidents that might be a result of that as well. Pressure points, here's people working on their knees. Guy on the right is using a cart to scoot around. So as he has to move, he doesn't have to get up, and he's got padding on the cart as well. I think the guy on the left might be wearing knee pads. I can't tell for sure. Static work, we're just talking about feet, and here's they sell cushions specifically designed for people that are on their feet for long periods of time, for behind a counter and so on and so forth. Personal protective equipment, gloves, properly fitted gloves, and so on. Shoes, proper shoes for working in that environment also. Organizing work so that you're not needlessly making extra motions and repeating motions over and over again. Okay, so basics of an ergonometric program. If you put together a program for your workplace, first thing you want to make sure is that all the workers are represented. You don't want to ignore people that have repetitive issues. You don't want to be focused on people that are complaining. You want to also deal with people that in the future may develop issues as well. You want to actually involve the worker, because they'll give you a lot of insight in how they do the work, how they handle the materials, and what's causing them issues. You should review your medical surveillance data. In other words, look back and see what kind of injuries that you've been experiencing, and if a lot of them, which of them have to do with ergonometric issues. You might see a spike in ergonometric cases after the implementation of program. Why might you see a spike in ergonometric cases after you implement the program? Remember I was telling you, did I ever tell you about the first indoor air quality job I did, where we had a small area, one floor, where somebody was complaining, and this was a company that had multiple floors, like 20 floors that they occupied in the building, and then one person that was complaining that they smelled something funny and it made them faint and so on and so forth, and pretty soon few of our co-workers were complaining as well, and they decided that rather than get this tested, You know, we have so much space that's unused on these other floors. Let's take these people that are complaining, just move them to another office where they won't complain. You know, they won't be experiencing this. Well, of course, we went to the other offices, told everybody they had air problems on that floor, on that other floor. So now all 19 floors were complaining. Well, once you start to pay attention to this, people that didn't recognize that what their issues were ergonomic problems will you'll increase awareness of it. And in fact, you might see a little bit of a feedback on that in the spike in the reported cases, because before that they weren't recognizing this any more than the employer might have been recognizing that he was losing productivity to this kind of stuff. So yeah, so you have an employer that's constantly missing time, not showing up for work, and so on and so forth. Turns out he has an ergonometric problem. It's carpal tunnel or something like that. So now the employer and the worker are, you know, at least aware that what the issue is. Shared prevention and responsibility is shared by both the employer and employee. The employee actually has to implement this. He actually has to change the way that he does his work in order to make this thing work. Determinative training is needed. Identify the goals, develop learning activities, evaluate training effectiveness, and improve the programs. Always helps also put the program into writing as well. Worker training should include how to recognize and report signs and symptoms early, hence the increased incidence of, in the beginning, increased incidence of reported cases. How to recognize hazards, ergonometric hazard, how to proper work practices, procedures, and how to use the right equipment. What equipment might help them as well. You want early detection because these can turn into chronic injuries. A minor carpal tunnel issue, if you catch it early, can be managed. If the worker continues to be injured, it may wind up in a surgery and really extended lost time and productivity. And, you know, in comp cases and so on and so forth. How many of you guys, any of you guys deal with comp cases? You maintain comp records? Anybody? No? How does workers' compensation work? Anybody explain to me how workers' compensation works? Say in any New York State, for instance. Why do you get compensation? Yeah.
Yeah, worker gets hurt and companies like employers have programs where workers
Yeah.
get
No, they don't have. The state has it.
State has
It's an insurance program run by the government, run by the state. Federal government says everybody's got to have workers' compensation. They can either have federal workers' compensation or they can have state workers' compensation. All the states want their own. They don't want to have to deal with whatever the federal government may force them into. So they all have their own programs. Alabama has their program. New York has their program. Arkansas has their program, right? All they cover the same things. They have to have a minimum standard for coverage, but it's a trade-off. What happens is workers exchange their, and this has been legislated, workers exchange their right to sue their employee for injuries on the job for workers' compensation. So you can't sue you. If you get injured on the job, you can't sue your employer. I hate this, you know, I hate to say that absolutely, because nowadays there's third-party lawsuits and lawyers trying to get around that, and so on and so forth. So that's not an absolute protection for the employer, but for the most part, you can't sue your employer. In exchange for not losing the right to sue your employer, the state legislature has said that we set up this program of, if you're injured, you can now go to a doctor, get a compensation doctor, get approved for compensation, and you can, you know, like either leave work, get reduced workloads, and so on and so forth, and recover from the insurance fund money. Might be a quarter or a 30. It's not a windfall, right? Might be a 30 of your salary or something like that you're getting on workers' compensation. But that's an exchange. That's an insurance program. Workers' comp, though, who pays for that? The employers pay for that, right? So the employers pay for each employee they have, depending on what kind of industry that they're in. If you are in a typing, if you have what do they call it when they have a lot of programs, coding pool or whatever, you're like a coder or something like that, and you have a computer outfit, right? You probably don't pay very much in the way of workers' compensation, right? Because injury rate's very low. You don't get very many people getting comp that are working at a computer screen. And they're probably younger population as well. If you're a roofer, your workers' compensation rates are through the roof, right? That's not meant as a pun. right? Through the roof, because roofers have a lot of injuries, right? They're falling all the time, right? They're nailing things into themselves. They're doing things all the time. They have a high injury rate. That's the nature of the industry. You pay a higher rate. In addition to that, if your rate is higher than what industry category that you pay a multiplier. If your rate of workers' compensation payments are, say, 20% more than your industry group on the average for the number of workers that you have, you pay that much more. You have a multiplier. You pay that much more in workers' comp insurance. That's why employers don't want injuries that are on comp. They'll keep a guy working somewhere else, give him a different task, and so on and so forth. They'll try and avoid, because what happens is that that sticks with you for 3 years. If you have a couple of major injuries and guys are out for extended periods of time on workers' comp, and now all of a sudden you're at 30% over the rate for your injury in terms of lost time and workers' compensation, you now for the next 3 years are paying 30% more for your insurance, your workers' compensation insurance. In addition to that, if you go over a certain level, like I don't know what it is in New York State, 1.25 or something like that, you have to call in a safety consultant to review your whole safety program and make changes and pay him and so on and so forth in order to, because you're so much above your industry group. You don't want injuries. You don't want repetitive stress industries, because they involve a lot of comp payments, right? If you're out for 2 days, you don't go on comp, right? Because you have to be out for a certain period of time. If you're out for 3 months because you had to have carpal tunnel syndrome, you're a comp case, right? A expensive comp case. So they don't want these cases. So acute injuries, if you can keep them from becoming chronic and winding up getting worse, it's great for everybody. It's great for the employee. It's great for the employer, because he winds up better productivity. He doesn't have to train another worker, take that guy's place while he's out, and it may keep that worker off of workman's compensation, which is good for him because he wants to make a salary. He doesn't want to make a fraction of his salary. Most workers don't want to be on workers' comp unless they got an angle. The only reason I never saw a worker that wanted to be on workers' comp is because that brother-in-law that had some other job for him that he could do off the books. Every other worker I ever know doesn't want to be on workers' comp. They want to be at work making their normal salary. Okay, so early treatment save time and money to return and help return to work early. So yeah, so these kind of injuries that like really can be extended, be very expensive for everybody. Place or report signs or symptoms. Pain is persistent, severe, or worsening. Pain radiates. Again, you want to catch it early as possible so you can deal with it. Symptoms include numbness or tingling. Symptoms keeping you from sleeping at night. That's really important, because you don't sleep at night, you're not productive. You're more likely to get into an accident. You're more likely to drive and fall asleep at the wheel. So, it really affects your not sleeping, not getting enough sleep at night because of pain. It can really affect every aspect of your life. Conclusions: ergonomic injuries are serious, can inhibit quality of life of employees. I think we covered that, right? Inflicting serious cost of workers' compensation, time away from work, decreased productivity, recognition, key in reducing. I got a message here. Hang on a second. Oh, hang on a second. Just for you guys, a message. The AIHA student group is meeting tomorrow in room 503. And there'll be Tamara Mitchell from Coca-Cola. She's a CUNY alumni. I think she was in my biostat class, Tamara. I think she was. Okay, from Coca-Cola. She's working for Coca-Cola. That should be pretty interesting. And she's a CUNY EOHS alumni. And say hello to her for me. Okay, Bill? Thank you for bringing that up. That's by all means, you guys, all of these kinds of organizations, it's about time to go. All of these kinds of organizations are great for networking. When you need to find somebody that knows something about something you need some help with, you know where to go to. If you need an ergonomist, you know who to go to. If you're working somewhere, they need somebody to do this kind of work, or you need some help with it, you know who to go to. If you are looking for a better position, another job, You have, if you join the Metro New York AIHA, you have 100 people that are in your corner that you can talk to that are working for utility companies, working for manufacturing companies, working for Coca-Cola, and so on and so forth, that know where these jobs are. Okay, so have a good night, guys. I'm going to post, there's going to be one more homework, which is going to be a combination of a few questions on ergonomics and a few questions probably on vibration from next week. And then the last assignment is I'll present you some issue or it can be kind of a small composition or essay on evaluating either a study or some document or some case study or something like that and giving us feedback on it.
Do we have
So-
another exam?
No, we do not have another exam. I would love to have another, would you prefer to have another exam? No, okay, okay.
Online?
What's that? Yeah, it would be online, yeah, I would do it online.
Is it better than the
You-
critical
you-
appraisal?
You want, yeah, you want to know something? I could actually give you a choice.
Can we?
Right, yeah, I could give you a choice of doing an exam on this and what do we, non-ionizing radiation, ergonomics, and vibration. You know, nothing real, nothing ridiculously challenging, right? Or doing the critical appraisal.
I like that.
Right. So you guys, you gotta have a choice on that. Okay, so I'll do that. So you can figure that by the second week, end of the second week of December, I will post either the exam, I'll post an exam and something for you to do a critical appraisal on, and you'll have your choice of which of the two that you want to do. Okay?
Yeah.
Okay, guys, good night.
Yeah, did you post, I saw there was something about homework 5.
There's a homework 5 on non-ionizing radiation. That's the same homework I handed out last week.
Okay, I missed that.
Oh, okay. It's on Blackboard. I handed out last week as a Word document, right? I think it's like 8 or 9 problems or something like that. What I did was I turned it into a test on Blackboard. So if you did it on that sheet, all you have to do is go there and put the answers in.
Okay.
Right? So it's a good spot for you to throw the answers in. If you haven't done it, you can just work on Blackboard from that.
And that's
You have 2 copies on that I handed out that are on Blackboard under that week 11, right? One copy is the problems themselves. The second copy is the problems with the equations for each problem, kind of like hints. So if you can, try it the first way without me giving you the equations. But if you're having issues with it, then just go to the other one where you actually have the equation in front of you.